Welcome to Lesson 3.1, Organizing Your Data, Lists, Tuples, and Sets. In the world of data, single values are rarely enough. We often need to manage collections of information, whether it's a list of customer orders, a set of unique product IDs, or fixed configuration settings. This lesson is your gateway to understanding how Python helps you organize this vast amount of information efficiently. By the end of this session, you will be able to identify the core characteristics of Python's list, tuple, and set data types. You'll also learn to create and perform basic operations on each of these collection types. And, most importantly, you'll be able to choose the appropriate collection type for different data organization tasks. This foundational knowledge is crucial for anyone looking to build robust and scalable systems, allowing you to manage complex data structures with clarity and efficiency. Think about a major search engine. It doesn't just process one search query, it handles billions of queries, web pages, and user preferences every day. Or consider a large social network. It manages millions of user profiles, friendship connections, and photo uploads. If you tried to store each piece of information in a separate, individual variable, your code would quickly become unmanageable and incredibly inefficient. This is the challenge of unstructured or poorly organized data. Without proper tools, managing related pieces of information becomes a tangled mess, making it difficult to access, update, or even understand your data. We need efficient ways to group, store, and manipulate related data points, which is exactly where Python's collection types come into play. They provide the structure needed to turn chaos into order. To tackle this challenge, Python offers powerful built-in collection types. Let's think of them like different organizational systems within a well-structured library. Imagine a library where every book, every shelf, and every catalog entry has a purpose. Our data isn't just floating around, it's organized for efficient retrieval and management. Each collection type, lists, tuples, and sets, serves a unique role, much like different sections or tools in a library. Lists are like a shelf of books in a specific order, perfect for sequences. Tuples are like a book's fixed publication details, ensuring immutability. And sets are like a collection of unique book titles you've read, where duplicates simply don't exist. Understanding these distinctions is key to choosing the right tool for the job, allowing you to build more robust and efficient applications. First up, we have lists. In our library analogy, a list is like a shelf of books arranged in a specific order, perhaps a series. You can see which book is first, second, or last. The key characteristics of lists are that they are ordered, meaning the items maintain a specific sequence, and they are mutable, which means you can change, add, or remove items after the list has been created. Lists are incredibly versatile and are one of the most commonly used data structures in Python. You'll use them whenever you need to store a collection of items that might change over time, such as a list of project tasks, a sequence of sensor readings, or a user's shopping cart items. Their flexibility makes them ideal for dynamic data that needs frequent modification. Let's look at how we actually work with lists. Creating a list is as simple as enclosing items in square brackets. To access an item, you use its index, remembering that Python uses zero-based index, so the first item is at index 0. Modifying an item is straightforward. You simply assign a new value to a specific index. Adding items is often done with the .append method, which adds an item to the end of the list. If you need to remove an item, you can use the .remove method to delete a specific value, or del with an index. These operations are fundamental to managing dynamic data, allowing you to build systems that adapt to changing information, like updating a list of available inventory or managing a queue of customer support tickets. Next, we have tuples. In our library, a tuple is like a book's fixed publication details, its title, author, and publication year. Once these details are printed on the book, they generally don't change. Tuples are similar to lists in that they are ordered and allow duplicate items. However, their defining characteristic is that they are immutable. This means that once a tuple is created, you cannot change, add, or remove its elements. This immutability is not a limitation, It's a powerful feature for ensuring data integrity. You'll use tuples for data that should remain constant, like geographic coordinates, RGB color values, or a fixed set of database credentials. They are often used when you need a sequence of items that you can be certain won't be accidentally altered during program execution. Finally, let's explore sets. Continuing our library analogy, a set is like a collection of unique book titles you've read. If you read the same book twice, it doesn't get added to your read list a second time. It's already there. The defining features of sets are that they are unordered, meaning items do not have a specific index or sequence, and they contain only unique elements. Duplicates are automatically removed. Sets are incredibly efficient for tasks like checking for membership, is this item already in my collection, or removing duplicates from a list. You'll use sets when the presence of an item is more important than its order or how many times it appears. Think of managing a unique list of email addresses for a newsletter, or identifying all distinct tags associated with a blog post. They are powerful for operations involving distinct values. With lists, tuples, and sets in your toolkit, the crucial next step is knowing when to use each one. This isn't about one being better than the other, it's about choosing the right tool for the right task. If you need an ordered sequence of items that you'll frequently modify, like a queue of tasks or a shopping cart, a list is your go-to. If you have a fixed collection of related data that should never change, like a database record ID and its corresponding name, a tuple provides that immutability and data integrity. And if you need a collection of unique items where order doesn't matter, and you'll often check for membership or remove duplicates, then a set is the most efficient choice. Making these informed decisions will significantly impact the performance, readability, and maintainability of your code. We've covered a lot in this lesson, and you now have a solid foundation in Python's core collection types. You can now identify the distinct characteristics of lists, tuples, and sets, understanding what makes each one unique. You've also learned how to create and perform basic operations on these collections, giving you the practical skills to manipulate data. Most importantly, you can now confidently choose the appropriate collection type for different data organization tasks, which is a critical skill for any developer. This knowledge empowers you to manage diverse datasets efficiently, leading to cleaner, more effective code. As a self-assessment, consider this. If you wanted to store a list of all the unique skills required for a job, which Python collection type would be the most suitable, and why?